discuss another important parameters to describe the two-port networks, that is transmission parameters. Transmission parameters are also called ABCD parameters. The main application of this transmission parameter is to analyze the transmission lines, mainly used in power systems. Right? Now we discuss transmission parameters. Transmission parameters, also called ABCD parameters. These are mainly used in transmission lines, that is power systems, power lines or power systems. Okay, then already you know that so maybe transmission lines like this. These are something transmission lines. Okay, these are the just a model of a simplified circuit of a transmission lines. Okay, this is some, let us say, so this is some transmission end, this is some receiving end. Transmission and receiving end, or source and transmission end. Generally these transmission lines are modeled in terms of RLC components only. RLC components. So modeling of generally we describe transmission line in terms of something like RLC component and something. Okay, this is some receiving end, this is some transmission end. Okay, like that these components are distributed throughout these transmission lines. Okay, this can be, now let us here it is. Here it is V1 and current I1. Now coming to here it is V2 and the receiving current is now come to the two-port network. It is a two-port network. The generalized block diagram is I1 current and V1 and here it is V2 and here it is I2. But compared to this one here in transmission model, this is transmission line model. I2 is outgoing current. So how we can represent means here the I2 current in this direction, now minus I2 current in this direction. Here the important note here is I2. Here very important note is mainly concentrate on I2 current direction. Okay, now we consider the minus I2. Okay, here this is I2, so outgoing current. But in two-port model we represented I2 into the port, but a minus I2 outward from the port. Now ABCD parameters. ABCD parameters are simply transmission parameters. Here V1, I1. Port 1, this is input port. Okay, this is output port. Port 1 input voltage, input current, completely described in terms of port 2 voltage and current. So A into V2 plus B into I2. Similarly C into V2 plus D into I2. Okay, these two are equations used in transmission lines. But here the direction of by using it can be represented in matrix form, that is equal to A, B, okay. Here it is minus I2, minus I2. A, B, C, D. Here V2 minus I2. This is the T matrix. This is also known as T matrix or transmission line matrix. Right? Here the negative sign only to the current, minus I2 current. Don't write here minus in B and D, right? Minus only for current direction. Now here same equations can be written as V1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2. Okay, this is third, this is fourth. This third and fourth equation mainly used to analyze the problems. To represent matrix form, you can use 1 and 2. These two are used to represent a matrix form. These two are used to represent matrix form. And these two are used to analyze the problems. Okay. So to analyze problems, all these things, we consider V1 is equal to A V2 minus B I2. I1 is equal to C V2 minus D I2. That means complete port 1 input voltage and input current completely described in terms of port 2 voltage and current. This is the only one parameter which describes the input parameters in terms of output parameters. Now we discuss by using open circuit and short circuit. Find one by one. These two are the basic equations used in transmission line parameters. Now we find one by one. Now A is equal to V1 by V2 when I2 is equal to 0. Okay, when I2 is equal to 0, that is open circuit. Open circuit reverse voltage gain. A is equal to open circuit input by output reverse voltage gain. There is no units, gain, open circuit reverse voltage gain, V1 by V2. Okay, generally people used for convent, people use 1 by A. 1 by A is equal to V2 by V1. So V2 by V1 is open circuit when I2 is equal to 0. Open circuit forward voltage gain. Open circuit forward voltage gain. A is equal to open circuit reverse voltage gain. 1 by A is equal to V2 by V1. Now it is very easy to measure the voltages. Suppose we apply some voltage V1 here, then measure the voltage at output port. Okay, now this is the first parameter. Then similarly second parameter, C parameter. C is equal to I1 by V2 when I2 is equal to 0. Same C also, open circuit. Okay, input current by voltage. So reverse transfer admittance. Reverse transfer admittance. Now it is better to find 1 by C also. 1 by C is equal to V2 by I1. V by I. Okay, here the units are moves. Here I2 is equal to 0. So voltage by current, that is impedance. Open circuit, forward transfer. Open circuit, forward transfer impedance in terms of ohms. Right, these are the A and C. Now coming to third, B. Here B means minus B is equal to V1 by I2 when V2 is equal to 0. When V2 is equal to 0 means short circuit. Okay, V by I. So short circuit, reverse input by output current, reverse transfer impedance. So minus 1 by B is equal to sum I2 by V1 when V2 is equal to 0. Short circuit, here it is output current by input voltage. So forward transfer admittance. Forward transfer, here it is ohms, here it is ohms. Okay, that means we are applying some voltage here. This is a network. We apply some V1 here, then measure some current I2 at output port. So it is better to calculate values. So fourth parameter, it is a C, A, D. D minus D is equal to I1 by I2 when V2 is equal to 0. That is short circuit. Okay, input by, it is a current gain, reverse current gain. Reverse current gain. So minus 1 by D is equal to I2 by I1 when V2 is equal to 0. Short circuit, forward current gain. Short circuit, forward current gain. Okay, these are the four transmission parameters, right? Once again, here A is equal to when I2 is equal to 0. I2 is equal to 0 means open circuit. Open circuit V1 by I2 when I2 is equal to 0. That means we are applying some voltage here. Here it is a V1. Then measure V2 when I2 is equal to 0. It is difficult to measure in real applications. When I2 is equal to 0, V2, right? Okay, instead of that, measure 1 by A. 1 by A is equal to V2 by V1. That means apply some voltage V1 and consider the network. Find output voltage V2 at output terminals. Okay, so that is 1 by A, open circuit, forward voltage gain. Like that remaining also find for each and every one reciprocal. A 1 by A, C 1 by C, B 1 by B, D 1 by D. So these are the transmission line parameters, and there is other names for these parameters. Okay, simply it is a T parameters, and second name is because here this transmission line RL and here C, here G, these are distributed throughout this one. Cascade or chain parameters mainly used in cascade networks or chain network parameters. And third one is general circuit parameters. General circuit parameters. Okay, these are the other names for ABCD parameters. T parameters, cascade network or chain network parameters, or general circuit parameters. Now we discuss one small problem, then how to calculate ABCD values using transmission line analysis. Now here the problem is, okay, consider the problem here. That problem here it is, okay, 1 to 5. Okay. Consider the network here, T network, 1 ohm, 2 ohm, 5 ohm. It is V2. Here it is V1. And it is minus. For that one, find, for this one, find transmission parameter. Okay, here it is, find T parameters. Okay. Now we know that basic equations used in T parameters, V1, I1, A into V2 minus B into I2, C into V2 minus D into I2. Now we find one by one. Okay. A is equal to V1 by V2 when I2 is equal to 0. Again draw the circuit. Here it is 1 ohm, 2 ohm, here it is a 5 ohm. Here the condition is I2 is equal to 0. I2 is equal to 0 means open circuit. Here it is V2, here it is V. Whenever I2 is equal to 0, if there is no drop across 2 ohm resistor, no drop across 2 ohm resistor. Okay. Now what happened when there is no drop means here also this is also V2. Then apply voltage divider. What V2 is equal to V1 into 5 by 1 plus 5. Then that is equal to, we require V1 by V2. So V1 by V2 is equal to, that is 6 by 5. That is equal to A. So A is equal to 6 by 5. There is no units here. That is a gain. Reverse open circuit, reverse voltage gain. Then similarly find C. C is equal to I1 by V2. Under same condition I2 is equal to 0. And consider here the same network, that is the same 1, 2, it is a 5, Here it is the V2, that is open circuit here, because I2 is equal to 0. And here it is V1, and current flows this loop is I1 current. There is no drop across 2 ohm resistor. Now here it is a V2. Then V2 is equal to, in terms of I1 into 5. Now here we require I1 by V2. So from that, I1 by V2 is equal to 1 by 5. Okay, 1 by 5 mhos. Now find remaining parameters, that is B parameter. Okay, here the B parameter is, B is equal to V1 by V2 B parameter is equal to V1 by I2 when V2 is equal to 0. When V2 is equal to 0 means that is short circuit. Consider the network here. It is 1, 2, 5. Here it is V1 and this is short circuit. V2 is equal to 0. Okay, this is V1. Now find V1 by I2. Now here the current is, I1 current. Then first find I1. It is I1 is equal to V1 by total resistance 1 plus, these two are in parallel, 5 into 2 by 5 plus 2. That is equal to, I1 is equal to 7 V1 by 17. Once you know the I1, then I2. Apply current divide rule. Apply current divide rule. So what is I2 is equal to? I2 is equal to, okay, already we are considering the minus B. Okay, no problem. I2 is equal to I1 into opposite resistor by total resistor. So what is I1? I1 is equal to 7 V1 by 17 into 5 by 7. 7 get cancelled. So that V1 by I2 is equal to, here V1 by 517, here it is I2. Now V1 by I2 is equal to V1 by 17 by 5. This is equal to minus then last one, D parameter, that minus D is equal to I1 by I2 when V2 is equal to 0. Okay, consider here the same, this figure. Same, apply current divide rule. What current divide rule? Apply current divide rule. Consider this circuit here, this circuit. It is I2 is equal to I1 into opposite resistor by total. Now we require I1 by I2, that is equal to, I1 by I2 is equal to 7 by 5. So that is equal to minus T. Now total overall T matrix T matrices. This is the T matrix. A value 6 by 5 and B value 17 by 5 and C value 1 by 5 and D value 7 by 5. Okay, this is the T matrix, and we may put some minus to the current, not for A, B and D. Now here it is V1, V1, I1. Okay, V1, I1 is equal to some ABCD into V2, I2. Okay, these are the values. Like that, you have to find using open circuit and short circuit method for transmission line parameters. Thank you.